This is the Lancair Legacy. She was designed by Lance Niebauer and manufactured by Lancair International in Redmond, Oregon. She's offered as an advanced composite kit aircraft made largely from vacuum-molded carbon fiber sandwiches and aircraft-grade aluminum. Her wing is cantilevered and a little more than 25 feet in length. It's actually a combination of a Cole CG-10 airfoil at the root and a CG-11 out at the tips. If you're familiar with airfoils, then you understand that this is a highly critical laminar airflow wing, which makes for one slippery aircraft. This Legacy is powered by a Continental IO 550N 6-cylinder 4-stroke engine, which generates 310 horsepower. She's fitted out with a 3-bladed, constant-speed, high-performance composite resin prop designed and manufactured by the Hartzell Corporation. I know you're familiar with the Cessna 172. Let me give you a little comparison. This aircraft is significantly smaller, lighter, more powerful, and more maneuverable. Her gross weight is less than 90% of a 172, yet she carries almost twice the horsepower. Her wing area is less than 48% of a Cessna's, but she's designed to accept a 63% greater wing load. Her aerodynamics and power give her a 2,000 foot per minute rate of climb versus a max of a little more than 720 feet per minute for the Cessna. At a cruise altitude of 8,000 feet, she'll carry 2 souls at 245 knots, with her max cruise speed being around 276 knots over a range of a little more than 1,100 miles. Her service ceiling is 18,000 feet, and she'll hold about 65 gallons of 100-octane avgas. Depending upon her weight at the time and local density altitude conditions, she'll take off and land within 850 and 900 feet respectively, and she's rated for an 18-knot crosswind. She's a fun aircraft to fly, but all this performance comes with a pretty hefty price tag. That critical laminar airflow wing stalls with very little warning. Clean and dirty stall speeds are 75 and 65 knots respectively. She wants to go fast and doesn't like having to slow down. She demands your constant attention and respect. You want to make sure this aircraft does not get ahead of you. Let's climb in and I'll bring you up to speed. Okay, now that we've completed our walk around and we're buckled in, let's take a look around. You're going to see that we're keeping this canopy open while I run through the cockpit familiarization with you. If we close it too soon, we'll get pretty warm in here. This is really a pilot's aircraft. You'll see the Sacred Six are located directly in front of the pilot. Above them, starting from the left, we have the master warning, a DME switch, and the landing gear, confirmation lights, and activation switch. To the left of the airspeed indicator are the elevator trim and the angle of attack indicators. The elevator trim indicator is self-explanatory. We'll talk much more about the angle of attack indicator a little later. To the left of the turn coordinator is a VHF nav 2 gauge. Starting from the left below the gauges, we have the magneto switch, alternator and battery switches, the avionics master, and then the lights, strobe, nav, landing, and panel. Next is the fuel pump switch, then the pitot heat, and finally the switch for the spoilers. To the right of that row of switches, we have the flap indicator and flap switch. Below the switches are engine alternate air and parking brake levers. Moving to the center area, and starting from the top and moving downward, we have the warning lights and annunciator panel, a Garmin GNS 530, 2 Bendix King KX155A nav and comm radios, and finally the Bendix King KFC 225 autopilot. Although the GNS 530 routinely handles the comm and nav radio duties, this aircraft has a redundancy built in just in case we sustain an equipment failure during flight. Below the avionics on the center console, we have from the left our throttle, prop pitch, and mixture levers. The fuel selector is next, and finally the rudder and aileron trim rocker switches. Back here between us is the canopy open and close lever. In front of you, we have a Vision Microsystems VM1000C engine monitor. Below that panel is a Bendix King KR87 ADF radio and a KT70 transponder. The last three instruments all the way to the right are the compass, a G-meter, and the ADF radio magnetic indicator. Rounding out the cockpit layout are your circuit breakers on the far right. Okay, I think that about does it. I believe you're ready to go ahead and get acquainted. Let's see if we can't get this canopy closed, and we'll run through the startup. Let's start the pre-flight. Parking brake goes on. All switches are off. Landing gear switch is down. The battery switch now is turned on. All three landing gear lights are properly illuminated, indicating the gear is down. We start to see the equipment warm up. There is the VM1000C, and you'll see that manifold pressure gauge is actually now recording the ambient outside pressure. Fuel quantities are good, 33 gallons in each tank. That's full. Let's check the annunciator. As you can see, the appropriate warning lights are all lit. All the lights light up. Hit the master warn switch. Trim tabs are in neutral, and let's set the altimeter. The canopy is down and locked, and the fuel selector is set to both. As you can see, the initial oil temperatures, EGT and cylinder head temperatures are all registering the ambient temperatures. There is of course no fuel pressure or oil pressure at this stage. And what we're seeing with regard to voltage and amps is simply a fully charged battery. Let's go ahead and put on our headsets and we'll start this aircraft. First, let's turn on the strobe lights so we let people know what we're intending to do. Take a look and see the prop area is clear. The next thing that we want to do is come down and turn on the auxiliary fuel pump. Now set your throttle about 1/4 of an inch. We're going to try to achieve as close to 1500 RPM as possible initially. That will help the internal fuel pump achieve the same fuel pressure. Move your prop pitch to full fine. Now as we move the mixture control, take a look and see at this fuel pressure. You'll see that it gradually climbs to 20 pounds. There it is right there. Alright, now let's start the engine. Come on over here and take a look at the RPM. Move your RPM up to very close to, right about there. That's good. Come down and turn off your fuel pump. Check your fuel pressure again, and you'll see that the engine now is maintaining a suitable fuel pressure. We're also looking at rising oil temperatures, and the oil pressure is satisfactory. The next thing we want to do is come down and turn on our generator. We want to make sure that we're achieving a good charge. Now let's turn on the nav lights and turn on the master avionics. Come on over here and let's take a look and see. Sure enough, we've got 28 volts and 20 amps, so the alternator's working just fine. On the left side, next to the trim indicator, is an angle of attack gauge, which has 3 color-coded regions, green, yellow, and red. This gauge is extremely useful and is a handy addition to the traditional way of assessing how near to a stall you are by reference to the airspeed indicator. The problem with just using airspeed in this way is that airspeed is not always a good indicator of how near the wings are to stalling. The angle of attack indicator gives instant information about how much lift there is available whatever your speed. When you're close to stalling this aircraft, whether by flying low and slow or executing a high-speed turn, the angle of attack indicator will let you know. The gauge is calibrated so that when approaching maximum angle of attack, the green and yellow display disappears and then begins to show red only, until that band of color also disappears, at which point you've stalled the aircraft. Let's go ahead and taxi down to runway 24. Kilo Hotel Quebec Mike traffic. Lancair 1151 Delta is taxiing to runway 24. We're going to stop here and do our run-up. We're looking for oil pressure above 55 psi and temperatures below 240 degrees. We're at 66 psi and the temperature is stabilizing at around 225 degrees. Voltages should at this point be above 24, and we're at 28. Amps are good and holding steady at 20. Exhaust gas temps are good. They should range between 1350 and 1450, and the hottest cylinder is holding at 1385. Cylinder head temps are also good. They should range between 385 and 485, and we're holding at 435 for the hottest cylinder. Fuel pressure is good at 20 psi and fuel flow appears normal. Alright, that takes care of our run-up and things look very good. Now we want to check the aircraft to make sure that we're configured properly for takeoff. First thing that I do is check to make sure that the autopilot is off, and it is. Our prop, of course, needs to be at full fine. The mixture needs to be at full rich. Our canopy is confirmed to be closed and locked. Our harnesses are tight. The takeoff setting for our flaps is 2 notches, so let's drop those down now. There's the first one. There's the second one. I've already established the takeoff position for trim, which is 33%. Nose up. I do one other thing, since this is a familiarization flight and we're going to stay close to home. I have set the HSI course to the runway heading. That always gives me a point of reference with regard to the runway. Before we let the community know what we're going to do, we do one other thing. I'm going to turn on this auxiliary fuel pump now. Alright, let's prepare to taxi out to the runway. Let's make sure that the area is clear. I see no one at this stage. Let's let the community know what our intentions are. Kilo Hotel Quebec Mike traffic, Lancair 1151 Delta taking off runway 24, departure to the west. Alright, let's take the parking brakes off, and we'll commence taxiing now. The Lancair Legacy is a high-performance aircraft. Depending upon density, altitude conditions, and weight, she will want to rotate at about 70 knots. Because of her critical wing and stall characteristics, I'm always more comfortable with a rotation speed of between 80 and 85 knots. Although this Continental IO 550 is capable of delivering a maximum takeoff power of 29.7 inches of manifold pressure, today's conditions warrant our using around 27 inches and 2,700 prop RPM. There's no reason to push the engine when it's not necessary. Rotate. Retract landing gear. Retract first notch of flaps. Retract second notch of flaps. Kilo Hotel Quebec Mike traffic, Lancair 1151 Delta, clear of the runway. Okay, we've established our initial climb and things look pretty good. Turn off the auxiliary fuel pump. We want to reduce power to approximately 25 inches of manifold pressure and then reduce the prop RPM to 2,500. As I mentioned earlier, this aircraft has a very critical wing. The Legacy's clean stall speed is 68 knots. I want to demonstrate a clean stall and recovery now so that you can get a feel for the maneuver. Kilo Hotel, Quebec Mike traffic, Lancair 1151 Delta is 1 mile south of the field at 6,700 feet, executing intentional clean stall, no spin maneuver. Okay, let's continue reducing power. Watch that angle of attack gauge. The aircraft will give you both physical and audio warnings. Push the nose down, neutral rudder and ailerons. Increase power gently. Once the angle of attack gauge indicates lift, gradually pull back, maintaining your airspeed. This aircraft will enter a vertical spin if you don't immediately take the correct remedial action when you enter a stall condition. The degree of severity and the persistence of that spin usually depends upon the amount of fuel you have in the wings at the time and the resultant centrifugal force. The Legacy responds well, however, to standard spin recovery techniques. Let me demonstrate. Kilo Hotel Quebec Mike traffic, Lancair 1151 Delta is 1 mile south of the field at 5,500 feet, climbing to 6,000, executing intentional clean stall with spin maneuver. Okay, that about does it for today. As you can see, she's a beautiful little aircraft. She has lots of spirit and she's eager to please. You simply have to respect her and understand her tendencies, good and bad. I really believe you'll enjoy flying her once you get to know her. Let's get ourselves some maneuvering room now and we'll let the community know we're going to call it a day. Kilo Hotel Quebec Mike traffic, Lancair 1151 Delta is 6 miles east at 3,300, inbound to land runway 24. Kilo Hotel Quebec Mike traffic, Lancair 1151 Delta is on downwind, runway 24. Kilo Hotel Quebec Mike traffic, Lancair 1151 Delta is on base, runway 24. Let's deploy the landing gear. Set the first notch of flaps. Now let's check our trim. Set the second notch of flaps. Kilo Hotel Quebec Mike traffic, Hotel Quebec Mike traffic. Lancair 1151 Delta is clear of the runway. While we're taxiing to parking, let's talk a little about the Legacy spoilers or speed brakes. The units installed on this aircraft are aftermarket options. Although we didn't use them today because we weren't in a position to do so, they are very effective. They are controlled by a toggle switch located just to the left of the flaps toggle. They deploy outward in scissor-like fashion, and both units add approximately 9 pounds. When you use them, they will actually double the aircraft's drag and normal rate of descent. I usually don't use them, but if you're ever in a situation where you've got to keep your speed up late into the arrival procedure, you can't beat them. Just remember to retract them once you've got yourself properly configured for your pattern, or you'll fight that drag all the way to the ground. You're flying a different aircraft with those things deployed. Okay, let's run through our shutdown procedures. Set the parking brake. Turn off the avionics. Turn off the lights. Shut down the alternator. Bring the mixture back to cutoff. Feather the prop. Turn the fuel selector to off. Turn the magneto switch off. Turn the battery off. Go ahead and stow your headset. Let's open up this canopy and go get ourselves a cup of coffee.